Okay, this is the first video for the IB Astrophysics option. And astrophysics is the study of space, and specifically the application of physics to space. Most of what we will learn about astrophysics concerns how stars work. But we need to get some of the basics down first, a little bit of astronomy. And the first thing is the solar system. You probably know what the planets in the solar system are from elementary school, but they go Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and Pluto is technically not a planet anymore. There is also an asteroid belt, meaning basically a bunch of rocks, that orbit between Mars and Jupiter. The four inner planets are all rocky planets and relatively small. The four outer planets are all gas giants. They're made primarily of hydrogen, and they're very large. Jupiter is the largest, followed by Saturn. Uranus and Neptune are almost the same size. I think Uranus is a little bit bigger. Earth is the largest of the rocky planets, followed closely by Venus. Then Mars, which is approximately half the size of Earth, and Mercury is the smallest planet. All of them have at least one moon, except for Mercury and Venus. Earth has one, Mars has two. I don't really know how many moons Jupiter, Saturn, Uranus, and Neptune have, but all of them have lots of moons. Saturn also has rings. You probably knew that already. In addition, you have comets, which spend most of their time way far away from the sun, but occasionally will come in on a highly elliptical orbit, swing very close to the sun, and then back out. And the comet is basically a chunk of ice. A bit of vocabulary. You need to know the difference between a constellation and a star cluster. Constellation, you look up in the sky, you see some stars that look close together. Maybe if you're very imaginative, they look like a bear. That's a constellation. There is absolutely no guarantee that the stars in that constellation are close together in 3 dimensions. Some of them may be relatively close, while others are very, very far away. So the constellation just looks close together from the Earth. A star cluster, on the other hand, those are stars that actually are close together, meaning they're all about the same distance from Earth, in addition to looking close together. And usually, star clusters are gravitationally bound, meaning the gravitational attraction that the stars exert on each other is what keeps them close together. Those are useful for astronomy because usually all the stars in a cluster are about the same age, and so you can look at stellar evolution that way. Now, there's a bunch of distance units in astronomy. The light year is one you've probably heard of. It's the distance that light travels in a year, so the speed of light times 1 year. And it's equal to 9.46 times 10 to the 15 meters. It's a very, very long distance. There's also an astronomical unit which is useful for measuring the distance within the solar system. It's much smaller than a light year. It's the average distance between the sun and the Earth. It's about 1.5 times 10 to the 11 meters. So a light year is approximately 50,000 astronomical units. There's also a unit called the parsec, which is equal to 3.26 light years. And we will see in a future video why the parsec is a useful unit, but it's frequently used in astronomy as well. Now, in terms of sizes, the galaxy is typically between 1,000 and 100,000 light years across. Milky Way is a relatively large galaxy. It's about 100,000 light years across. Something like the Magellanic Clouds that are smaller would be more like 1,000 light years across. And typically, galaxies are separated by something on the order of 1,000,000 light years. So you need to know about the distance scales involved. Now, when you look up in the sky, the stars appear to move. The reason for that is that the Earth rotates. And if you take a time-lapse photo like I have here, the stars appear to go in circles. And the dot here at the center of the circle is the celestial North Pole. And you need to know that stars move because of the rotation of the Earth is why they appear to move. There's also what's called proper motion of stars, where the stars actually are moving through space, but that is very, very slow and hard to measure from the Earth. The other thing is that some stars are only visible during part of the year. Now, here we have a picture of the Earth's orbit around the Sun. At this point, it is winter in the northern hemisphere. And this is summer in the northern hemisphere. And then this would be fall and spring. Now, if you imagine a star that's located here, that is only going to be visible in the winter, because in the summer, the sun will be in the sky at the same time that star is, and the sun is so bright that it basically overwhelms the light from all the stars that are in the sky with it. So a star over here is visible in winter. A star over here is visible in the summer. A star that's located above Earth's orbital plane, like the North Star, is visible year-round from the northern hemisphere, but never from the southern hemisphere. Whereas a star down here would be visible year-round from the southern hemisphere, but never from the northern hemisphere. And that is the basics of astronomy. It's kind of what you need to know in order to start talking about astrophysics. You need to know the distance scales. You need to know the difference between a constellation and a stellar cluster. You need to know why the stars appear to move. And you need to know the planets in the solar system and have some sense for what asteroid belts and comets and that kind of thing are.